retired wing commander from Indian Air Force. He has completed his undergraduate in electronics and communication and postgraduate diploma in personal management and industrial relations. He served as a senior production engineer, maintenance planning in Indian Air Force, followed by head aircraft maintenance and technical training IAF, senior engineer electronics in Indian Air Force, senior engineering officer for VVIP fleet, especially Boeing 737-200 and Boeing business jets in Indian Air Force. After his retirement, he has started his own company, actually two companies. One is Will Aviation Private Limited, which is in Coimbatore. It is concentrating on air charters and aerospace engineering services, aerospace consultancy, aerospace research centers, and air adventure sports. There is another company which is called D Drone World Solutions Private Limited, which is in Madurai and Coimbatore. It is completely related to drones, drone services, training, and creating center of excellence in drone technology for the institutions. He is having more than 25 years of aviation experience in diverse areas, including aircraft maintenance, aerodrome infrastructure, and technical training. Sir, we are indeed very happy and privileged to have you in this session. The session is yours, sir. Once again, I welcome you, sir.
Thank you so much for those nice words and introduction, Mr. Kumar, and good evening to one and all. Thank you very much for inviting me to this session, and it's my pleasure to be part of some of the elite minds in the country, and then speak amongst all of you. In the next hour or so, my effort would be to take you all with a basic introduction towards what the topic is, and then answer your queries if you may have any. Without wasting much of time, I'll start my presentation. Just 1 minute, please. I presume all of you are able to see the screen.
Yes, sir. It is clear, sir. You can proceed.
Yeah. Okay. Good evening, one and all. The topic for today's evening discussion is integrating multi-sensor fusion for enhanced drone perception and data analysis. As Mr. Kumar had already introduced, I'm here on behalf of D Drone World Solution as the Executive Director. We are a small startup with 3 years of operations. I would be taking my topic under the following heads. Initially, I would like to say what are the types of sensors which are used in drones, and then what are the various techniques which are there as used for sensor fusion, challenges in multi-sensor fusion, and applications and future trends. Thereafter, would like to take on any questions that you may have. The process of integrating data from various sources, primarily the sensors which are there in the drone, and then use that data to achieve a more accurate and comprehensive drone performance is what we are going to talk about today. This technique is basically aimed at enhancing the efficiency of the drone performance and the data that we would like to acquire utilizing the drone, so that we have a precise solution in our hands with the data that we can obtain. Here, I'll just briefly cover what we are going to cover. In fact, I'm going to talk about how multi-sensor fusion takes place. This is a small pictorial representation of the entire activity that takes place when a drone flies. A human observer starts flying a drone. The flight of the drone is being controlled by the manual actions of the human, or an automatic control system which you might have to enable in the drone. And this data is being the drone which flies obtains certain data, utilizes the data, and then use that data for the improving the performance of the human brain, or the data which can be utilized for a post development phase. This is exactly what we are going to see in what we mean by saying multi-sensor fusion. Why it requires, why a multi-sensor fusion is required, or what does it entail, is because there is a decision making which is being requested by everybody when you go in for a flight. Be it even a chinna, or I think even if you want to fly a small kite, there is certain amount of data which your brain and your eyes collate, with which you direct your the control thread so that the kite soars high in the air. So that's exactly what it matters, how well you are able to utilize or compare all the data that you acquire in terms of maybe the wind condition, maybe the weather, maybe the nearby objects which are going to be there wherein you're going to fly the kite. These are all the data that you are going to fuse into your mind, and then try to control the kite to fly in a fashion that you achieve a much bigger height to reach. Why and where is it being used? In real world applications, we can say starting from a navigation perspective to complex terrain mapping kind of data which can be acquired and used. This is why multi-sensor fusion matters to us. What are the challenges that are addressed by sensor fusion? As you can immediately understand, the limited perception or the autonomy of the flight can be addressed by having these sensor information fused. So, and a decision taken to overcome these two restrictions. And then when you don't have a sensor fusion, which means when you don't get data feedback, once you are restricted by line of sight or information which you perceive that is correct. That's where the drone sensor fusion addresses these issues in the market. Now let's see what are the components that involve in multi-sensor fusion. The components per se, if you take a drone, there are something called as an initial measurement unit, which every one of you are aware, which facilitates you in stabilizing your flight. A tilt sensor, a magnetic sensor. There are something called as an engine intake, air intake flow sensors, accelerometers, which can judge you how fast the fast or slow the drone is going to move. These are some of the basic sensors. When you go in for certain kind of advanced sensors which you can talk of, we can say in terms of high resolution cameras, the GPS coordinates obtaining in terms of maybe 4G or 5G networks, camera mounts per se, because they are all more or less like a tripods which can be rotated and then you utilize them. And then you have quite pretty modern ones such as laser rangefinders and optical flow sensors. These are some of the advanced kind of sensors which we can talk of. Broadly, we can summarize these types of sensors into visual sensors, in which we can say the sensor has got some sort of visibility in it. For example, it can be the cameras, the LiDAR, the IR cameras, which are the latest ones. And then these sensors, mainly what they do is they provide you a spatial awareness and then object or any obstruction detection. These are the advantages of having the visual kind of sensors. Second kind of sensors can be called as a positional sensors, where it facilitates you in keeping your position intact, which means like the GPS or the initial measurement unit in which the accelerometer kind of stuff comes into picture. This facilitates in positioning your flying object in a better way. So these are primarily meant for tracking their position, orientation, velocity, and then stabilization kind of stuff. That's where the positional sensors come into picture. The third kind of sensors are the range sensors, which can be ultrasonic or radar, which are which do not fall under visual or positional sensors, but these facilitate you in getting a data which provides to plan your future move or the next move, wherein there is an obstacle at a distance of 50 meters. These are the sensors which are going to give you a pre-warning that there is going to be an obstacle at that point of time. And the same corollary goes for the depth perception as well. And the last kind of sensors which we can say is the environmental sensors, wherein the environment makes a big difference in terms of flying. In day-to-day life, we generally hear to the news such as all flights in Chennai airport have been diverted because there has been a cyclone coming in. So how do you have that addressed when you do not have a longer term of flight maneuver for a shorter period? So these are the sensors which come into play, which play the role of temperature, humidity, and air pressure. And these give the primary basic information about the environment so that your flying is suitable to that kind of environment. So to broadly summarize, types of sensors are 4 types: visual, positional, range, and environmental sensors. Okay, so under these types, you can say basic sensors, you can say IMU, barometric, magneto, and gyros, which would form in the basic form. The second one would be the cameras, the LIDARs, and the third one will be the position ones and the GPS and the GNSS kinds of stuff. Now, coming on to each of the key components, IMU, as I said, it stabilizes, it's used for your stabilization of your flight. That's where the initial measurement units comes into picture. The role of cameras, it's all understood. It captures the visual data. LIDAR creates 3D models of the environment, so it facilitates you in forecasting your next step of flight. And GPS gives you the positioning and navigation in terms of environmental kind of details. And when you see IMUs, they are mainly in the UAV body itself, because the body is the one which needs to be stabilized. Unless otherwise you have the central body stable, your flight becomes difficult. So that's why IMUs are generally in the body, and these facilitate in that acceleration, rotational kind of movements of the flight, wherein you are confident that the drone is stable and it is balanced and flying comfortably. When we say of the IMU, you can divide it into, as I said, the barometric information. It gives that information to the flight control system, so that the flight control is able to stabilize your flight with regard to whatever changes that are happening in terms of the velocity or the acceleration kind of stuff. All this information is processed to control the motors and the servos, so that the speed can be adjusted and all that. This kind of system is used in almost all kinds of drones, be it fixed wing, multi-rotor, VTOL, or bionic drones, even in unmanned helicopters. Unless otherwise you have the stabilization system up and running, that's the base for the flight. As I said, cameras, they facilitate you in giving you a visible information about the obstacles which are there ahead, and then navigate you through a comfortable path, so that it facilitates you in a line following or an object tracking. In fact, you must have seen nowadays the sports and the movies of Ajit.
Sir, yes, sir. It is clear now, sir. Yes, sir. Presentation
Yeah,
also
okay.
visible.
Yeah, where did I stop? In fact, where did you miss my audio?
Sir, the same slide, sir. The camera.
Okay, types of cameras. Okay.
Yes, sir. Previous slide. Yes, yes.
Yeah, like there are various types of cameras with regard to specific applications. Some of them are like broadly you can divide them into visual, lidar, thermal cameras, multispectral cameras, and hyperspectral cameras as well today. So drone looking at a landscape with different cameras. I've just shown you the different variety of the eyes that see the land as it is, because each of the way you see things is going to make a difference in how you're going to utilize the data. So these are some of the various kinds of cameras which are coming to picture today.
Sir,
Yeah,
sir, can you maximize the screen, sir? It is-
yeah, just 1 minute.
Yes. Yes, sir. Fine, sir. Fine, sir. Thank
Yeah, okay. So the when you see it from a eye, there's a saying which says how you view things gives you a somebody. There's a famous motivational thing which everybody talks of. Somebody fills a half glass water and then asks each and everyone how you view the cup. Somebody says the glass is half empty. Somebody says the glass is half full. So it's the perception of the person, how you view the thing. So each way a camera can view provides different kind of an information to the data collector, so that he can perceive and utilize that information in the way that he wants to use it for. LIDARs, like today, this has been a very big order from the government that each and every land area needs to be mapped with drones. So LIDAR mapping has become a day-to-day affair today, because each and every project, be it a residential project or a industrial project, or for that matter, some of the tenders wherein you do mining in terms of even sand mining or rock mining or mining in sea beds, all of them require a LIDAR sensor, which provides you the data to facilitate how well you can go in for the mining. So LIDAR, as far as LIDAR sensor goes, it has got two parts. One is the hardware part and the other one is the software part. Some of the major ones, like you can see the UAV system and LIDAR system, or hardwares which are separately available in the market. Some of the famous softwares are DJI Pilot 2, DJI Terra, and those kind of stuff. And even today, nowadays, there are a few of the softwares which are being developed by our own country as well. Even some local softwares are coming into picture in the market. So this is another thing, like where you have a GPS denied area, where you use the LIDAR image to do localization and then merge the data for better landing. So you know where exactly you need to land, that you don't land up in the water body. If this kind of stuff where your GPS environment is not available is going to play a major role when we are going in for drone deliveries, because drone deliveries, in case there is a signal problem or anything, it should not be that the person is not able to deliver the item, or the drone is not able to land in the place where it has been intended to. That is one area where the LIDAR imaging also can come into picture. GPS, yes, it's a very simple equation. GPS today we use each and every one uses in GPS in terms of location finder or a map route mapper, or to go to one place, move from one place to another. So GPS is become a mandatory requirement in terms of if you have to look at some sort of location data or position reference to where you are. Further ahead, that also facilitates in terms of velocity estimation when you have a travel data, and the accelerometer is able to give you the speed with which you are traveling. And then GPS most important part is the time synchronization, because you always need to have time to be synchronized for any of your data to be correlated and taken forward. As I said, GPS is almost in every field. Some of the applications can be delivery, agriculture, and surveillance as well. Now, once we talked about these types of sensors, one major or important part is the sensor calibration and the maintenance, which is essential if you have to keep your machine up and running all the time. So I think sensor calibration and maintenance has to be known when we talk about different types of sensors. Why calibration is critical? Because each and everyone is aware of what drifts in values and the accuracy patterns. So calibration from time to time is very, very essential in terms of time stamping, as well as the margins of error that the sensor can create in your flight pattern, because those margins are also going to make a big difference. If the margins are not kept in within like if it has to be 10 plus minus 0.2, then it has to be plus minus 0.2. If the more it goes, then you're going into a larger error prone zone. So calibration's criticality is very much essential. Need for calculation, we have understood. I think that's self-explanatory. Another factor which you need to look at it, apart from the mechanical failures of sensors, is the dynamic environment, because even the temperature, pressure, and other environmental factor changes do affect the sensors. Because you know, when we speak of speed, pitot tube, and other stuff in an aviation environment, the temperature and the environmental factors also play a very big role in your sensor's performance, because a sensor working very fine in a 30-degree temperature may not function in the same fashion when it is being operated in Leh or Ladakh, where the temperatures go down up to minus 15, minus 20. So that's another thing which we need to keep it in mind. And then the manual and automatic calibration, because the calibration per se is also going to make a big difference.
Sir, voice, yes, sir. Now,
Yeah, it's okay.
now you're available. Yes, sir.
Okay.
Yes, sir.
Okay. I think we have been very monotonous in our topic because it's too hectic. So let me take a break and ask you a small question. Drones were deployed for crowd control in terms of public control and security. In which event in the world? It's ICC T20 World Cup 2024. The answer B is World Cup Football 2022, Olympics 2024, or others. Can we have the answers in your in the message column, please? Anyone? I think the question is clear. The drones were deployed for crowd control and security. In which world event? ICC T20 World Cup Cricket 2024, World Cup Football 2022, Olympics 2024 is C, and others is okay. There's somebody, Ravi Kumar says A, HOD Easy says C, Mr. Palani says C, Dr. Deepak says C. Can we have some more answers? So most people for C, it seems. Mr. Sendil Kumar Hicet also for C, Mr. Madan Kumar for C. Oh, that's nice. I think most of you are going in for Olympics 2024. Let me give you the answer. This is where it is. It was in no other place other than Madurai Chitrai Temple Festival. The drones were used for security in Madurai, and those of you in Tamil Nadu and Madurai will know Madurai Chitrai Festival is one of the famous world-renowned event which takes place where Alagar comes down to Vaigai River. You believe it or not, 2023 up to 2023, there has been at least 5 to 6 deaths and close to 10 to 20 thefts and chain snatching incidents in during this festival. You can Google it and see in 2024 there were not even a single incident of any of these during Chitrai festival. So the right answer is D, others. Yeah, nice. Thank you for those of you who have participated. Let's continue with our discussion. Let me talk something about once we have already known what are the types of sensors that we have been using, and now let's talk about what is this multi-sensor fusion is all about. Okay, we could understand that there are types of sensors and each sensor gives one input, and that input is being utilized for some sort of purpose. But now what is this said about multi-sensor fusion, wherein we are probably asking what is it? Okay, to define, I can say sensor fusion is combining data from multiple sensors. Okay, so now we are not talking about a single sensor. Yeah.
Sir, sorry to interrupt, sir. Can you full screen, sir? Can you please put it?
Yeah.
Yes, fine, sir. Thank you.
Yeah. Okay. Now we are talking about not one sensor giving one data and then we reacting to it. We are talking something about taking sensors, multiple sensors input, combining them, and then utilizing the combined output as a data to do something better. So sensor fusion primarily is aimed at enhancing the perception of the drone itself and then facilitate in a better decision making. So to put it very simply, it's the process of combining data from multiple sensors to improve the system performance for reliability or accuracy and etc. in terms of multiple applications. That's what we mean by saying multi-sensor fusion. Why is it necessary? Because it combines the strength, because each sensor has got different strength. As we have seen, different sensors have different inputs and the outputs that they provide. How you combine that to your betterment is actually enabling you to get a better strength. So, and combining some of the information, for example, some sensor is giving you a height-based information, the other sensor is giving you some sort of weather-based information. Combining this gives you a better reliability with which kind of environment the drone is getting into is known to the drone well in advance. That's the reason why we are looking at fusing the sensors information. And then the third and most important thing is, unless otherwise you have you have a GPS data, you have a temperature data from the temperature sensor, unless you join these two, you are not able to go in for a real-time information of the location as well as the circumstances in which you're flying. So real-time data processing needs multiple sensor data inputs to be combined into one particular aspect, then only it makes more sense. That's why a multi-sensor fusion is very essential. For an example, if I have to give a small example of a UAV in an urban planning and related sector, how does that work? There is some sort of a sensor which gives you some information about mapping and monitoring. Some sensor gives you some information about its operational safety in that location. Some sensor provide you an accessibility information, and another sensor gives you a high resolution imagery. So these three kind of inputs are taken over and then fused so that can be converted into a 3D modeling and a building infrastructure information, or facilitating you in terms of precision agriculture or a forestry, wherein you can track maybe in forest terms, you can track an elephant, you can track this thing. To do that, you need all the three kinds of information to be fused into one. Then only you will be able to get the required output for that particular application. This is why multi-sensor fusion is an essential commodity. What do we mean by integrating these sensor inputs? Like, say, for example, climate control sensors, wherein we have temperature, humidity, raindrops, light sensor, radiation sensor, and then in agriculture terms, soil analyzer sensors. Some sensor gives you soil moisture information. Another sensor gives you about soil content in terms of nitrogen, potassium, and the phosphorus kind of stuff. There's a sensor which gives you salinity information on the this thing. Now, at the same time, when you talk about the drone motion, the motion is controlled by acceleration, gyroscope, and all those stuff. And crop analysis can be done with camera, photosynthesis, and leaf moisture. When you combine the soil sensors with the crop analysis sensor information, then only that facilitates you in coming out with the best possible solution for that agricultural land which you are going to go in for, either spraying or deciding about which crop to cultivate in the land. So to summarize, integrating the sensor input means the process of combining data from various sensors. The benefits are it eliminates redundancies, improves the data accuracy, and provides a holistic understanding of the situation. Some of the algorithms used, we'll talk about it. So the third thing, now we have seen what are the types of sensors which we use and what is meant by a sensor fusion and how does it help us. Having known these two, now it's time for us to see what are the types of fusion techniques that are primarily employed. Broadly, I have taken the major ones which are being used in the industry. Sensor fusion techniques, like they can be called, or some of them are called weighted averaging. There's something called as Kalman filtering, which is a very famous kind of sensor fusion technique. Third one is a deep learning based fusion. So why fusion techniques important? We have already told you. This handles the noise as well as the uncertainties and gives a better performance. To give you a small explanation about the various kinds of techniques, the Kalman filter is a mathematical model. Basically, what it does is it takes the data, has a mathematical equation attached to it, estimates the state of system from that data which is already available to it, and then it's used for positioning and motion tracking. Basically, it's on the stabilization front. That's where, and it's purely a mathematical model. That's how the Kalman filter works. The second one is the particle filter, which is employed for all kinds of non-linear inputs which are being taken from the drone. Something in terms of SLAM, the so-called simultaneous localization and mapping information, wherein you utilize the drone's position of the camera and then or the GPS and then use that. So particle filter kind of fusion is being done for all kinds of non-linear inputs that you are getting. The complementary filters is one which does it from the basic sensors of the drone in terms of IMU and magnetometer, which facilitates combining these in stabilization alone. That's where the complementary filter comes into place. The Bayesian filtering is one of the techniques wherein it's very specific, very specific, which handles the noise aspects of any of the sensors. So there can be some sort of noise in the output of the sensor, which eliminates these noises and then gives that clear data or the clear sensor input to the predicting models. That's where the Bayesian filter things comes into. So these are the different varieties of filtering or the fusion techniques which are being used. Like this, in the Kalman filter, the latest is an extended Kalman filter, which again it combines not only the GPS, it also does the IMU and all things which were being earlier done by the calibration method. The SLAM I have already covered it, which primarily for the non-linear inputs which we get. Visual odometry is one which is typically only for a camera, so that with the camera input alone, you are able to judge the motion and the trajectory of the drone, and you do autonomous flying with the visual odometry pattern of fusion. Kalman filter, like to give you an example, there's a vehicle radar, there's a tracking, there's an alien UAV which flies, there is an UAV with a radar. So this vehicle radar can be made with some sort of mathematical model. The alien UAV and the UAV with the radar can take this mathematical model, calculate both this location, and then come out with the vehicle tracker radar tracking information given to the vehicle radar. So vehicle tracker. So that is a kind of thing which can be practically used. That's where your Kalman filters come into picture. These are being employed in abroad for all sorts of traffic management actually. Particle filter, as I said, it's a parabolic approach towards the tracking system for the nonlinear models mainly. This what it does is actually it uses the each information of nonlinear data into a position kind of particle, which are being handled to sort out the stabilization of the drone's position and its path. This is actually very essential in terms when you fly in a complex environment in a very complex environment for drone flying. Like data synchronization in multi-sensor systems, like synchronization, as we have seen, it's combining the sensor data. The challenge is the time mismatches or data format differences. There's one sensor gives the data in one format, and the other sensor gives in a different format, and then there is a difference between the time stamping of each of the data which is coming in for fusion. So how these are overcome? One is utilizing the timestamp, it matches and then takes the fusion technique forward, so that same timestamp the data is combined in a same time place. Second one is interpolation, or interpolating the data when the synchronization is not perfect. In the sense when you combine the data, you interpolate it so that you know that the time stamping is absolutely not correct, but you are able to interpolate with respect to the data which has come with regard to the position or other stuff. Then you combine that and then you take the synchronized data. Third one is kind of hardware triggers, where multiple sensors are given instructions to record the data and send at particular points of time, so that which are being sent by a hardware trigger. It has been timed and triggered to such a fashion that those sensors start functioning only that when the trigger is received and the data is received back. So the triggered data is collated and then the fusion is being taken through. These are various ways in which you overcome the synchronization issues which might happen. Again, to give you a small example, when there are sensors which can which give you a camera, audio, or scalar sensors, all these data are primarily sent to CPU as well as mobility actuation units, servos and the motors for their functioning. The data is again taken back to the communication subsystem and the coordination subsystem, where these sensor interface stack works, and then they give you a feedback, and then that is forwarded again back to this mobility actuation units. This is the way that stabilization or things can be done with fusing the sensors information. Again, another thing is, like say for example, we have multiple sensors. One is an IMU, the second one is a camera, third one is a GPS. Now IMU gives a coordination calculation, and the camera gives a range positioning, and coordinate system gives exact location of the coordinates where it is. So all these are tightly coupled for data fusion, and then based on optimized information, then that data is being forwarded to the UAV positioning data. So when all these three are fused and then the positioning data is taken back, then the flight becomes very comfortable or the stable one. But now coming on to a field kind of an information. Now there are different. The data collection is done by the drone. Physical data transfer is done to a field computer. So when we don't have a real-time data fusion not being done, the entire data is taken to an office component where the data fusion is done in various methodologies, and then they are uploaded to a cloud or server component so that those can be utilized for your future flights. This is another utilization of your sensor fusion. Okay, again, let's take another break. The second question, and I expect more responses this time. Drones are deployed for traffic monitoring. Like as I mentioned, we were talking about traffic monitoring and traffic handling with drones. This is done in which city in the world? Answer A is Dubai. Answer B happens to be New York. C is Singapore, and D is others specified. Can we have the answers in the messages? Anyone? Bengaluru? No. Okay. So somebody for C, Mr. Londe, Dr. Londe is for C, Mr. Suprit for Bengaluru. Okay, Miss Tirumalai Kumari is for D, China. Mr. Madan Kumar is for Los Angeles. Yeah, some more answers. Okay, we have somebody with C and most with going with D with options of Bengaluru, China, and Los Angeles. Yeah, there's somebody, Dr. S.S. Mohan Reddy says it's in US. Okay, Mr. Suresh Kumar also says it's D, but which is the place, Mr. Suresh? D is others. You need to specify the location which you want to say. Yes, Mr. Suresh, D. Which one do you want to choose? Okay, nice. I think most team wants to go with D. Others. There was only one person who wanted it as New York, maybe US. He meant B. All others meant for D. Okay, the answer is here. Eyes in the sky. Jaipur police is set to find traffic violators using drone technology. It's in Jaipur in our own country. The date also you can see it's on October 2nd, 2024. So it's not that we are anywhere behind Singapore's and Dubai's and US. India is fast moving than what you and me are aware of. So don't worry, your days are not too far off, wherein we are going to see drones doing traffic monitoring in Chennai, and not only big cities like Chennai and Delhi. We are going to see it in, as we are seeing it in Jaipur. Things might be there in Pollachi and Coimbatore as well. Yeah, let's continue and let's see some of the challenges in multi-sensor fusion techniques and understanding the hurdles in integrating the sensor data. As we have already seen, multi-sensor fusion is crucial for enhancing the performance. And despite the various advantages that we have already seen, the key challenges are there, wherein which affect the fusion techniques. Okay. Some of the challenges in multi-sensor fusion are: one is data inconsistency. The biggest one is data inconsistency because the sensor readings may vary in accuracy in format, leading to challenges in getting the data to be assessed for the perfect output. The second one is on the computational complexity with which you have to handle the data fusion, the sensor data fusion, because some of the data is in different formats. So those stuff needs to be addressed, and sometimes the data is so large that you need to have really complex systems to do the data fusion. Third one, as I have already covered, is the sensor calibration. When we talked about sensors, I had mentioned how important a sensor calibration is. And then the last and the least, wherein you don't have any control, is the environmental factors like the weather interference, when the drone goes near a very hot surface, there can be differences in readings and all those stuff. So these are some of the challenges that the multi-sensor fusion takes. First, coming on to the real-time fusion challenges, then like in a real time, when you want to do a sensor fusion and utilize it on real time, which means for example, a drone delivery system, wherein you need to have real time fusion of the data which is being obtained, so that the further flight of the drone can be controlled, requires high computational requirements in terms of speed, bandwidth, and other stuff. Second one is the synchronizing the data, which I already mentioned. Now, some of it can be overcome by time stamping and other stuff, but otherwise, that's again a very big challenge. Managing latency and bandwidth issues, we have grown from 1G, 2G, 3G, 4G, and we are on the doors of 5G. What mobile phone we used probably 2 years back, today that cannot be used because of the memory issues and the other stuff, the speed of the processor and all that. So this is going to be an ever evolving subject of technological advancement. The fourth one is the communication technologies which are employed for real-time data exchange, like how you do the communication exchange between real-time data collection and your backend place where the data fusion is to take place. So the communication technologies, as all of you are aware, we have also come across so many communication technologies. We have grown across IEEEs to RS-232 onwards. We have grown up, and we have been going in for higher communication technologies. That's another thing which is going to be a big challenge. Some of the challenges is it's again it's a developing field, developing technology. So hardware modernization and improvement is happening day to day. Algorithms again have been becoming complex and growing day by day. And then distributed processing, in terms of some of the data processing can be distributed to different localities. Different kind of fusion techniques can be employed at the parallelly, and then get the data back faster. That's some of the real-time fusion challenges and the solutions that can be there. Second thing is how you handle the sensor noise and the other stuff which are assisting. Noise, as you are aware, all sensors are susceptible to noise. How well we overcome that noise in terms of frequent calibrations or the improvement in sensor technology is one thing which we need to look. The second one is the outliers, the rare, but these also have a big impact in disrupting the fusion algorithms which function to combine the data. Noise reduction, as I said, we can always look at Kalman filters and particle filters to handle these noises. The environmental factors, the examples I've already given you, the weather conditions, rain, fog, dust, and other stuff. Electromagnetic interference, EMI, is another thing which we need to cater for. And then third one is obstacle avoidances, which are moving obstacles. That's again going to be another interference for your flight. I'll give you a small example. Like you have a microcontroller which has the hill climbing algorithm, which is being given to the stepper motor, which controls the data. Whereas the entire receiving coil and battery charger can be affected because of the EMI issue, wherein your coil receives it in a different fashion and the data gets disrupted. Another thing is the big data in sensor fusion, because when the voluminous of the data increases, it increases the fusion challenge as well. Storage and processing of high frequency sensor inputs is again a big challenge. Some of the most advanced cameras that are coming in today provide you data which are in multiple MBs and kind of stuff. So data analytics is a big issue to improve your operational accuracy. A small example can be analyzing multi-flight data for route optimization. When you have 5 flight data, if you have to analyze them and then put it into a better flight route, that is going to be a challenge for you. Like complexity of the algorithms, as I said, there are very complex algorithms which are coming into picture day by day. Non-linear behavior can be reduced with terms of SLAM and particle filters. Adaptability, again, with changing environment, these algorithms are being changed, and sensor performance over times are being corrected with experience and knowledge. Data inconsistency across sensors, with different sensors giving different kind of data. Yes, the only way to come in is divergence in the measurement types. And like you measure the same thing in different formats, so that you can have approximation to the data inconsistency. As I have already covered, the real-time data processing challenge, it requires high computational demands, the latency issues, and the edge computing methodologies which you need to use in terms of real-time data processing at a faster pace. The third thing which I mentioned about is the communication protocols, because that's one thing which is evolving with technology. Some of the wireless protocols like 4G or 5G with Wi-Fi, and some foreign companies use the Zigbee as well. These are the protocols wherein these are still being standardized, still being improved upon. So there is a requirement of low latency and the high bandwidth systems which needs to come into picture, so that you are able to communicate or get the data or get the sensor data fused when you have higher bandwidth systems. These things are going to come into picture more into problematic areas when you're looking at urban logistics and drone deliveries, and then even the swarm drone technology, which has become a headache in present day wars of Russia, Ukraine, and Israel and the Hamas kind of wars, where swarms have been playing a very big role. Now coming on to the applications, what are the applications of multi-sensor fusion? I have been giving examples. If I have to broadly bring them into some of the headings, autonomous navigation is one area where multi-sensor fusion is mandatory. Then only your autonomous navigation and autonomous flight is possible, because individual sensor input is not going to facilitate you in an autonomous navigation environment. Second one is on the search and rescue front, where environmental perception is also going to have a big role. You must have seen the news recently. There was a girl who was lost in the Amazon forest, and she was located utilizing a drone. That's another thing where search and rescue area, where your multi-sensor fusion is going to play a role. Agriculture, as I gave you a full-fledged example, soil conditions, temperatures, and the crop health monitoring systems has to happen only when you have multi-sensor fusion data available to you. That's when you can effectively use a drone for a modern agricultural utilization. Environmental monitoring, the climate change and the whole world is being green economy, green ecology. So environmental monitoring, again, it requires different sensor fusion to have a positive impact onto the data. Some of the smaller things for your own drone operation is battery optimization. Like when you have a sensor data fused and given to the data to the battery, to the drone, the battery utilization becomes much better. When you have a smart navigation information or adaptive power management through real-time data, then your operational efficiency of the drone is enhanced. That's the local advantage or application of the drone per se itself. The example can be power conservation, doing idle state, and then route recalculation time periods. It can save its power. And aerial surveying and mapping, where LIDAR and GPS are there, you get high accuracy and faster processing data. So these are applied in city planning, mining, and environmental monitoring kind of stuff. This is another picture wherein it shows you the effectivity of each drone in every kind of environment. Like a drone can have a base station information controlled from an SDN controller and communicate between drones, and then provide data to a ship which facilitates its movement. The application can be recalled, like even with the information regarding agriculture we have already spoken. and controlling traffic and all those stuff. So this the applications are plenty, and it's up to your own imagination. And we have more question to
Yes, sir.
yeah.
Now you are available, sir.
Yeah. Did you see the question? Yeah.
Yes,
Mr.
sir.
Ajit is B. Yeah, Mr. Ajit's statement is B. Mr. Evelyn Diju is A. Mr. Madan Kumar seems to be C. Ms. Dr. Mohan Reddy is D. Ms. Kandasamy Jaya is B. Ms. Banu, yeah, is a really answer. Okay, the crowd seems to be divided between A, B, and C. Any more answers? Anybody more? The question I repeat: drone deliveries in India is already done in yesterday. It's happening today. It's going to happen tomorrow, or it is likely to take more time. A, B, C, and D. Okay. Dr. Mohan Reddy says 1 year back, they stated 1 year back. Okay. Mr. Alisha Bodavalu says B. Ms. Kailash Karnakaran says B. Okay. So most answers now are happening today, which means B seems to be a larger answer today. Okay. Let me give you the answer. TTDC launches drone delivery services in India. This is on July 29, 2024. Drone deliveries of medicine, groceries to residents in Gurgaon is being undertaken. This is almost again in 2024. Blue Dart begins drone deliveries. This is on June 19, 2024. So, gentlemen, drone deliveries is an affair of yesterday in India. It is just a matter of time. It is going to come into your and my place that these things are going to happen. As I said, the world is changing more faster, and India is also changing much faster in a big way. So it is the drone deliveries have happened as on yesterday in India. Okay, now let's come on to the summarization of the applications. As I said, autonomous navigation, precision agriculture, search and rescue, mapping, surveying, inspection, monitoring, delivery, and logistics. In every field, we are going to have the applications of sensor fusion. If I have to say AI-powered drones, then in the future, we have human drone symbiosis also going to happen. Cross-domain applications might come into picture. Edge AI and 5G integration might happen. Ethical AI and responsible deployment is another area which is going to come into in a big way. And advanced sensor fusion and multimodal perception things, algorithms can come into picture. Autonomous navigation, as all of you are aware, autonomous navigation facilitates a drone's ability to detect and avoid obstacles in a real time. It combines the inputs of cameras and lidars as well. Agriculture, I have explained in a very big way. It can combine data from the RGB cameras, thermal sensors, and then sensors from the ground as well, so that precision agriculture is made feasible. Search and rescue, I gave you a proper example of how it had been done. This picture show you how well you are able to locate a search and rescue mission, which gives you information from the visual cameras, infrared sensors, and the GPS, and combined into sensor fused, and then you get the data. Mapping and surveying, again, integration of the lidar, GPS, and high resolution cameras give you perfect picture of how a photogrammetry or drone land mapping and survey can be carried out. Inspection and monitoring, I had already mentioned, the inspections are happening in a big way, starting from railway inspections to electrical wire line, cable line inspections. thermal camera and RGB sensor inputs are being used to fuse, and then the data is used for their maintenance. Delivery and logistics, all information with regard to GPS and the radar is used for the delivery and logistics sectors as well. Future directions, as I had already mentioned, AI and machine learning is going to play a picture. 5G is again going to be a change maker, and edge computing is going to be again another this thing. Deep learning for sensor fusion, deep learning of algorithms is also going to be a big deal, because how well the algorithms change will make a big change in the entire setup. Real-time sensor, as I already said, that is going to be big game changer for the autonomous flying conditions. This is one of the small photograph of where how integration of hardware kind of sensors can be done utilizing a drone. Edge computing, I have already mentioned how you are able to calculate the onboard data processing to make a real-time decision. Future trends, advanced autonomy is one thing. AI-driven drone swarms is going to again play a very big field. In fact, you must be seeing drone laser shows and drone light shows, which have already started happening in our country. That's where your AI-driven drone swarms come into picture. Edge AI, AI again is going to play a very big role. 5G, 6G networks for the data communication networks and data processing bandwidths will be facilitated with 5G and 6G. And then AI-driven environmental monitoring also is going to make a big play in that. Before we conclude, let me take you to a small talk about what we are and what we do. Just take a minute. Yeah, the Drone World Solutions is a small startup. We are registered under MSME, and we are partnered with TIDCO, and our other firm, which I mentioned, is the Will Aviation. We are a partner with the pioneering central government pilot training institution in the country, named the Indira Gandhi Rashtriya Udan Academy, in partnership with IGRUA. The MOU was signed in presence of the Honorable Governor of Telangana, then Srimati Tamilisai Soundararajan, and the Honorable Minister for Civil Aviation, Shri Jyotiradittya Scindia. Our RPTO, or the Remote Pilot Training Organization, was inaugurated by the Honorable Chief Minister of Tamil Nadu. We do all kinds of drone activities, starting from drone education in terms of DGCA drone pilot licensing, specific drone piloting courses such as agriculture, survey mapping, or photography, videography courses. And we also get into drone professional course, and we do lots of internships, project works, and custom-made training for depending upon the college or the school information. We are the official training partner for drone technology with the Tamil Nadu government flagship skill development program, namely the non-Mudalvan. Our aim is been something to say in Tamil, Yer Munai Mudal Por Munai Varai. Abdindra Mari, start from agriculture, move on to the battlefield kind of aim and vision. That's where we are working on. We are having a good amount of partnerships with huge amount of academia, government, as well as industries on board. Our partnership, we believe in terminology of join hands to walk farther rather than walk alone. So we have been joining hands, and our partnerships have been growing almost on a day-to-day basis in a big way. And before I say bye-bye, let me introduce myself. I am Wing Commander A. Satish Kumar, retired Executive Director of the Drone World Solutions and Will Aviation Private Limited. I'm basically a B Electronics and Communication Engineer. Did my Masters in Aeronautical Engineering Management. I have done several management degrees in various specializations: human resources, industrial relations, project management, and international business. And presently, I'm pursuing entrepreneurship. I initially started my career with Antonov 32, a Russian transport aircraft specializing in passenger, cargo, parajumping, and bombing role, and also VIP transportation. I'm an Israeli unmanned aerial vehicle expert in Searcher Mark II and Heron unmanned aerial vehicles, which are presently used by Israelis against the Hamas. I'm an Israeli expert on this particular kind of unmanned aerial vehicles. I'm an DGCA, Director General of Civil Aviation, approved licensed aircraft maintenance engineer in Boeing 737-200 in 3 different fields as electrical engineer, electronics engineer, instrumentation engineer, and radio radar expert. My specialization is in Boeing business jets. The present aircraft which the Prime Minister utilizes has been under our leadership modified in USA. I'm a Boeing factory trained aircraft engineer onto Boeing business jets. Incidentally, these are photographs of 100th BBJ was the one which we collected, and I was the head of the fleet. Wherein we took over the aircraft. I was fortunate enough to be on the first flight on the first BBJ with the first woman president when we did the Air Force One flight in India. I'm an expert in the electronic warfare, electronic countermeasures, ECCM, and DS, and I'm US Air Force One Big Basari systems.
Sir? Sir, you're not audible, sir. Satish, sir. Participants, if you have any questions, you can post. Yes, sir, it's fine, sir. Yes.
Yeah, okay. So I'm an expert in Navy corrosion prevention and control program, M7 communication radars, and work with Tata on MAFI and HAL on arrestor barriers, and Army on the junior commander course. Some of the awards I've received is I was commended by the Air Officer in Chief by the headquarters of Eastern Air Command for our Kargil operations, and then we won the Best Technical Training Award by the Prime Minister Narendra Modi in the year 2015-16. And presently I serve several colleges and autonomous institutions in the Board of Studies, and some of the as a consultant with defense PSUs and government organization committees. I'm a member of Board of Studies with SRM, VIT, and IIT Gandhinagar. I have been fortunate enough in making the syllabus for the next academic year on composite materials. This is the closest to my eyes, and awarded by the President of India, Dr. APJ Abdul Kalam. Have traveled a long way. We do Desam Kakum Nesa Panigal Abdin Soli Indu Tamil. We do a program on to promoting opportunities for youngsters to join defense forces. Have come in most newspapers to headlines and other media aspect as well. That's it, and I think we have come to the end of the day. Would be my pleasure to answer any of your questions.
Yes, sir. Participants, if you have any questions, you can post it in the chat box, or you can unmute and ask directly to our resource person. Sir, I think there is a question in chat box from Ravi Kumar.
Just a minute.
You want some suggestions related to the courses?
That is some courses, sir, to incorporating ECE curriculum. Yeah, ECE is my favorite subject because people think everything is computer science, but I would say the base and backbone is ECE. As I said, there are several aspects that you can look at incorporating into an ECE curriculum, be it hardware based or even programming based for the microcontrollers to your developing modern communication protocols. So there is huge amount of things that we can do. I have already flashed my mobile number and my mail ID. We can communicate it over a call or mail in details. The second question is from Mr. Palani. What are the importance of composite materials in drone technology? Yes, this is one area which, as I said, technological advancements have been taking place in a very big way. Composites play a very big role in terms of the entire hardware part of the drone. I think there is this lot of studies which have gone in and a lot of work which has gone in epoxy as well as carbon fibers kind of stuff. Even in fact, today I was coming across something onto aluminum, something on magnesium as well. So this is again, I do have a research paper on composite materials in drone technology. I'll share it with you so we can communicate later. The next question is from Mr. Madan Kumar. Sir, for autonomous navigation drone, can we develop an autonomous camera with any kind of filters through multiple sensor fusions? Kindly suggest some filters, sir. I think it's again, it's up to your research and imagination to take shape. There's nothing impossible. There's nothing that you cannot do, and there is a scope in the idea which you have mooted. I think that's an area where we can work on. Yes, to be precise, yes, we can do that. And even the filters, these some of the filters I covered are all basic and which are in the market and which are evolving over a period of time also. They are not remaining constant. So even you coming out with a fresh option also would work. Next question is again from Mr. Palani. Which composite materials will be used, either metal matrix, nano composites or natural composites? As I said, I'll share you details. Mr. Ravi Kumar Rayala shares some open source tools for evaluating obstacle avoidance based on fusion sensors. Can I have Mr. Dr. Lodha? Please go ahead, sir.
Hello, sir.
Yeah, please, sir.
First of all, thanks for the wonderful session.
Thank you.
I have one question, like, for example, drone has to move from position A to position B. Okay.
Okay.
So there are n number of ways that drone can reach to position B.
That's correct.
So how it reach to position B? What is the method, or how he choose the route to reach to the position B? Whether it is waypoint tracking or whether it is reference tracking, or what are the control methods?
Primarily, everybody uses GPS. Everybody has again in the flight planning, the shortest route to the destination is what the software works out and gives it. There are in non GPS kind of enabled surfaces, you give a point to go as well. So when you open up a flight planning software and do it, you understand it in the very easiest fashion, sir.
Okay, sir. And what are the control methods employed usually?
See, but that's again not only autonomous flights, even manual ways, and it's all on you to decide what you want to do.
Okay, thank you, sir.
Yeah. Mr. Madan Kumar has said, thank you, sir. Thank you so much.
Yes, thank you, sir. I think if there is no more question, thank you, sir.
Yeah,
thank you so much, sir.
Yeah, thank you so much for the session, and look forward to meeting you all. Yeah.
Yes, sir. Thank you so much, sir.
Thank you so much. Bye-bye.
Thank you, sir.
Participants, kindly hold on for another 2 minutes. We will be starting the second session. As requested earlier, we are trying to get a presentation from all the resource person, and we'll be sharing it by today or tomorrow, so that you all can prepare for the assessment which is going to be held on Saturday. Okay, so I think it's time we'll move to the second session for today. Without any delay, we'll go to the second session. I'm indeed very happy to welcome the resource person for the second session, Mr. Arulmolinathan. He's an assistant professor in Department of Aeronautical Engineering, Hindustan College of Engineering and Technology. He did his Bachelor of Engineering in Aeronautical Engineering from Katpagam Institute of Technology, Coimbatore. Master of Engineering in Aeronautical Engineering from Park College of Engineering and Technology. After his education, he worked as a junior design engineer in Janani Equipment, Coimbatore, where he is responsible for designing and design validation. After which he worked in SB Industries, Coimbatore as quality supervisor, where he was responsible to ensure quality products are being delivered to the clients. He has published 2 book chapters and under a drone domain. One is Internet of Drones, Application Challenges and Opportunities. The second chapter is IoD Enabled Swarm of Drones for Airspace Controlled, both published by CRC Press. He has published various papers on aerodynamic and drone technology. He has guided more than 25 UG students in their project related to drones and swarming of drones. He is also currently serving as an entrepreneurship cell coordinator, and also he has completed his MHRD Innovation Ambassador Program, and he is working with students and encouraging them to start their own startups in drone technology and other possible areas. So with this, I welcome my friend who's a part of our department, Mr. Arulmolinathan, to take over the session. Sir, you can start, sir. Arul, I'm not hearing you, Arulmolinathan, sir. I think you need to.
Okay,
Yes.
I think yes, I have unmuted it. Am I audible now, sir?
Yes, you are audible.
And I hope my screen is also visible.
Yes, sir.
The presentation is visible. Okay. Thank you for the warm introduction, sir. I'll take the session from here on. Good evening, participants. For session 6, the topic that I was asked to talk about is a swarm of drones. So, to start with an overview of drone swarming, swarm is a collective of any animals or birds or insects that behave in a particular pattern to achieve a common goal. So the same term is being used for drone, so that a collective of drones will work together to achieve a common goal. So this is inspired from nature. So if we have to define what is a swarm of drones, it is a group of drones that work together to achieve a common goal inspired by the behavior of animal swarms in nature. By coordinating their actions, they can achieve tasks that are too complex for dangerous for individual drones. So, for example, if I have to say, we all have known the V formation of geese for managing its aerodynamics to minimize its energy consumption and maximize the efficiency. So, its drone swarm also can be manipulated in such a way to optimize its flight path and distribution to achieve its desired outcome. So that's what we are going to see how and by its means. So where it get inspired, it's from, like I said, from animals, bees, and insects and birds. These 3 things, flock of birds, ant colonies, and bee swarms, these 3 things are the main inspiration for drone swarming. So in the flock of birds, what we can see it is that it has a very coordinated flight pattern, which demonstrates a high efficient collision avoidance and cohesiveness amongst themselves. Then in ant colonies, we can see ants following a particular trail till the end of the task. They communicate using pheromone trails. They have a collective efficient navigation and task allocation amongst themselves. Some ants monitor the other ants. So the last one is the bee swarms. When we see a swarm of bees, it is always in a very disturbed pattern, in an irregular pattern. There is no pattern at all, if we have to say. So it demonstrates a decentralized decision making individual bees to contribute to the overall collective behavior. So as a collection of bees, they attack or they collect honey and they complete their task. They are involved in a particular task, but they do not take any commands from another individual bee. They themselves do it on their own. So these three things, flock of birds, ant colonies, and bee swarms, either on a single stand or combination of these concepts can be an inspiration for the swarm of drones. So basically, what are the characteristics of swarming system is one is autonomy, another one is coordination. So when it comes to drone swarming, the current system is that we have multiple drones connected to a single remote, but the piloting error or the amount of data that has to be given, instruction that has to be given to a swarm is high. So it has to be an autonomous one. So drone swarms should operate with minimal human intervention, relying on onboard intelligence to adapt to the changing environments. And the next one is coordination. Coordination, when it comes to a swarm of drones, it can be 5 drones, 10 drones, 100 drones, 1,000 drones, or even 5,000 drones put together. So these drones has to communicate amongst themselves and synchronize their action in real time to achieve a shared objective. So the characteristics of a swarming system is basically autonomy and coordination. So what are the principles behind these drone swarms is the first one is swarm intelligence. The second one is Boyd algorithm. The third one is communication. Instead, if I should say Boyd algorithm or an algorithm that can be developed in future using these combinations of this biomimics that we have. The swarm intelligence implies the collective behavior of drones and utilizes algorithms to achieve a shared goal without centralized control, which means the drones on their own should be able to complete their task. So what is Boyd algorithm? That is a rule-based approach that simulates flocking behavior and promotion, separation, alignment, and cohesion based on birds, which can be utilized for drones. The last one, but the most important one and the most challenging one, that is the communication. The communication technology that we have today, if we need 1,000 drones to swarm for a particular objective or multiple tasks, the communication is a bit lagging. So the communication should be wireless, and because they communicate using wireless protocols like radio frequencies, Wi-Fi, or IoTs for enabling real-time coordination. So what are the technologies that enable this swarming of drones to be a possibility is artificial intelligence, then communication protocols, and the recent development of sensors and vision systems like LiDAR, GPS, and IMUs, and onboard cameras. The communication protocols should be a low latency communication, and artificial intelligence AI algorithms will empower real-time decision. So these three things are the basic technologies or the foregoing technologies that will take swarming into the next level. So what is the current progress of drone swarms is that uh, getting it integrated with the Internet of Things, then AI-driven autonomy, and implementing them for urban application and underwater exploration. But this underwater exploration, the communication system and patterns are totally different from aerial. So how do we introduce this UAVs to Internet of Things? So late from in the 1800s, unmanned aerial vehicles were commonly started to evolve. In 1844, I think, uh, balloons were used to attack uh, Venice in Europe. They would tie some explosive device or something to a balloon, which will go to a particular altitude and collapse under pressure, and those explosives will fall on the city. So even 100 years back, people wanted an unmanned aerial vehicle for their combat or their usage. And during after the world wars and advent of communication technologies and ECE people, uh, UAVs were much implemented in military applications. But now, in the recent times, UAVs are very much employed for civilian applications also, like disaster management, delivery, and surveillance. So, combining Internet of Things with UAV or UAV with Internet of Things for real-time communication and autonomous operation, we can call it as Internet of Drones, which will be a future scope for the swarm technology. Now, if I have to define the Internet of Drones, these definitions are subjected to change when the technology enhances. If I have to define it, I can define it as Internet of Drones is a combination of IoT and drone technology to enable autonomous flight and data exchange, allowing drones to communicate and collaborate with each other and with ground station. So this is an apt statement that is required for swarming. Then what are the key technologies that enhance this Internet of Drones is the IoT itself, then cloud computing and big data, where IoT allows drones to collect and transmit data, while cloud computing provides infrastructure for data storage, processing, and analysis, where big data analytics helps extract valuable insights from the collected data. On seeing what are the components of Internet of Drones, normally for a UAV system, we have the UAV itself, then the communication system, and a pilot. But here we have the UAV system, the communication system, and AI integration for processing large data for autonomous decision and complex tasks. So by this, the human intervention can be reduced to a greater extent. Other than that, the UAV's components and the communication requirements will rely the same, but the communication requirements will be very high when it comes to integrating with the internet and AI. Now, how do this AI work? For giving us a typical example, for instance, let me say if there is a 10-story building that is caught up with fire. Say for instance, the seventh floor of the 10-story building is caught up with fire, and the firefighters are fighting on the east side of the building, trying to put off the fire. But the fire is progressing on the north side, which is not visible to the firefighters. Now, if we are enabling 5 drones connected to each other and communicating to themselves, they can detect the hotspots and monitor the fire progression on the side which it is progressing and communicate to the human firefighters. This is a typical example how drone swarms can be implemented. So after that example, what are the basic components of drones? That is the frame itself, the propellers, the motors, electronic speed controllers, radio transmitters, sensors and cameras, battery and electronics, and flight control boards. These are the normal components of drones. Now, if we are enabling the swarm of drones with IOD for airspace control, there is a lot of potential to revolutionize this airspace management for drones. Anybody who is operating a drone and involved in drone technology, we know that there are several zones for operating drones and we have to get a required permission. So this airspace control is very typical and very crucial when it comes to government policies, and it has to be very carefully crafted when either it is being a civilian application or a military application. So if we are designing a system architecture for this swarm of drones technology, the first thing that we have to do is the intra-swarm communication, where drones with the swarm communicate with each other via wireless mesh networks, sharing information about their location, status, tasks, either it be avoiding a collision or staying within the boundary limits, and etc. So that itself is a huge task. If the number of drones increase and if the application varies, then that itself is going to be a huge research area. Then the next segment is the swarm cloud. This is a new term, a swarm cloud, where one particular swarm of drone can be dedicated to a particular task. That is surveillance. If, say, for instance, some 20 drones are for Coimbator's police surveillance, and another 5 drones are for medical emergency, another 20 drones are for agricultural purposes, and some other drones are for logistics. If the surveillance drones detect a particular accident or some case, a medical emergency in a particular area, then it has to communicate with the medical drone swarm to act appropriately, and do the needful. So a swarm cloud, I can say it is a combination of swarms, multiple swarms, each swarm dedicated to its own purpose. Then the third segment will be the cloud center, where the cloud service will process these large amount of data collected by the drones, performing very complex analysis, optimizing the swarm behavior, and providing insights for decision making. So there is going to be a lot of data transmission if a large number of drones are going to be involved. And even for a single autonomous drone, there is a considerable large amount of data that has to be transmitted for making its own judgment. Now, in airspace control, what are the challenges that currently that we are facing is that the significant challenges are collision avoidance amongst the drone itself, and collision avoidance, collision between the drones and some other obstacles that may be on their way. Then swarm boundary management. If the 5 drones are progressing together for a particular task, they should stick to their boundaries, communicating amongst themselves. One should not leave its boundary, and it should not go beyond its area. Then maintaining the desired formation, how they have to complete that task. That is important. So these three things in an airspace control are challenges, and they are as well as the opportunities for researchers to showcase their abilities in making new architecture algorithms and new system of drones and getting their own patents. So some strategies that are proposed by the previous researchers in the latest edition are leader follower mechanism, then behavior based formation controls, and decentralized judgment makings. So in the leader follower mechanism, a single drone will be directing other drones, which other drones will be following it. So before getting into the aspects, a small information is that how fast the drones can fly in a civilian application. That is around, they can reach speeds up to 45 miles per hour, and some models can even hit up to 70 miles per hour. That is over 100 kilometers an hour. Racing drones often exceed 100 miles per hour. That is like going beyond 160 kilometers an hour. The world record stands at an incredible 360 miles per hour. That is more than 500 kilometers an hour. So why is the speed and the operational speed of the drones is important is that when they are operating as a swarm, if they are moving fast, if they have to avoid collision, then this velocity will play a very important factor, because the communication signals should be fast enough to the drones to avoid the collision. So let us see a typical drone formation pattern here. This is a simple sketch that will give us a vision over how a formation can be done. This is a multiple layer swarm formation where there are three batches of drones, A1, A2 and A3. And this A1 is supposed to be the leader drone that communicates with A2 and A3. But whereas A1 also communicates to its homies, that is B1, C1 and D1, and A2 communicates to B2, C2 and D2, and A3 communicates to B3, C3 and D3. So these type of communication will happen amongst the drone groups and between the different groups also. And these drones can be operating in different layers. In layers in the sense, they can be in different altitudes or in different frequency or different regions, or operating to different applications. This formation is simply to give a vision of how this will communicate, but in actual we can make it as a ring formation, linear formation, V formation based on their application. Whatever formation that we require, we can make the swarm to form. To imply this, we need a strong swarm coordinate system. The first one is the leader drone coordinates, where the position of the leader drone is configured, and the position of the follower drone will be configured using follower drone coordinates. So these coordinates will decide the behavior and the boundary management for the drone system. So there are some typical behavior of drones which we have to imply to them. That is homing behavior, that is moving towards a particular signal, then cohesive behavior, staying close to each other as a cluster, then following behavior, distinguish the leaders from the batchmates and follow appropriately. So if there are 5 drones, all of them are going to be of same size, and the sensors will be similar. So the follower drone should know that it is a follower drone, and it has to take its signals from the leader drone, which in turn will communicate to the other leader drones. Then dispersion, to maintain minimum safe distance inside the batch. This will avoid collision between the drones inside a batch. Then alignment. Alignment behavior is to move in a coordinated manner with respect to the attitude. This alignment is an important factor in flight compacts also. The same way you can imagine the drones moving to complete a particular task. Then conflict-free behavior. For instance, let me go to the next thing, that is the boundary management. The boundary management is that if I consider in this figure, we can see that C1 and D1 are safely distanced, and the distance is given as a limit. Say for instance 5 meters to 10 meters is the distance that has to be maintained between C and D drone. In the sense, if C drone is facing some obstacle and is moving further left side and increasing its distance beyond 10 meters from C to D, C1 to D1, then the D drone should not fear the conflict of this nature, and it has to follow A1 only. So such thing is known as conflict-free behavior. So it will identify the location of the batchmate drones and avoid conflicting their decisions while avoiding an obstacle or while completing a task. So in air collision avoidance, we have a batch-wise collision avoidance, individual collision avoidance. The individual batches of drones, say for instance A batch and A1 batch and A2 batch, they should not collide for targeting a particular task, or if they have a common target and A1 is the first approacher, then A2 can wait until they complete their task, and they should not collide with their judgments. Then individual collision avoidance is the collision that has to be avoided between the drones inside the batches. And when the drones are moving at high velocity, in both the cases, the communication should be conflict free, or else stability of the drone will be impacted very much. So the formation of the drone system will not be in particular desired nature. The last one is the narrow opening or path. This is a typical case which will involve for, say for instance, if 100 drones are passing through a particular passage which is narrow between 2 buildings, I'll say. The gap between the 2 buildings is 10 meters apart, and the swarm width is about 30 meters, and there are 100 drones that has to pass through the 10 meters. The drones have to set up a queue amongst themselves to enter into that path. So there also this conflict-free behavior should be there, and the formation of queue where the ant behavior is necessary. So these applications are these kind of thought process is necessary for the drones to imply for a particular civilian application, or while surveillancing into a dense forest, looking for some unwanted elements inside the forest, and etc. So this critical decision has to be made. So what are the basic collision avoidance strategy? That is optimization based method, then forced field based method, and sense and avoid based method. This optimization based method is based on the velocity, direction, and distance towards the obstacle. So the drone will sense the obstacle or their location, and based on its velocity and attitude, it will change its course, and it will avoid collision. The next one is force field based method. Uh, they use attractive or repulsive electric field around each drone. This electric field technology, or this method, is having some issue with the electronics that will involve in the drones itself. But there is a significant improvement in the Chinese side for this method. Then sense and avoid based method, that is what we are trying to do using ultrasonic sensors or cameras or thermal sensors or whatever that we are capable to do. Identify the vicinity of the neighboring drone and maintain the distance and avoid collision. So this last one is the feasible one in India nowadays. Then the next is formation control. There are some strategies for collision avoidance. Now there are some methods for formation control. That is the leader follower strategy, then behavior based strategy, and virtual structure based strategy. The leader follower strategy, as we know, one leader goes and the follower goes, and the coordinate system will maintain the formation. Then the behavior based strategy is, we have seen some 7 types of behaviors in the previous slides: homing behavior, following behavior, conflict free behavior. Those combinations of those behaviors can be used for maintaining the formation. So the commonly used behaviors are cohesive behavior, dispersion behavior, and alignment. And these combination of the structures or behaviors are dependent on path or route of the swarms through which they undergo. For a forest, some other combinations may occur. For a civil and city, some other may occur. And in agriculture purposes, that may entirely vary. For instance, there is a virtual structure-based strategy where a group of drones is considered as a single drone and connected to a single computer or a single remote. We can program the group of drones in a particular grid that they have to move in this direction at this velocity at this altitude. So for instance, if we are having 100 acres of some farm, paddy field or something, and we have to spray insecticides, 100 drones can be put into a particular grid, and they can be engaged to a particular task of spraying that insecticide using smart agriculture techniques, which will be similar. So here we can see the swarm and obstacle coordination system. An obstacle for a swarm can be of 2 kinds. Either it can be stationary or moving towards or away from the swarm. So if this obstacle is stationary, then there is less amount of calculation that has to be done by the drones. It can figure out what is the dimension, what is the size, shape, and what is the location of the obstacle, and they can move accordingly, either left or right or top or bottom, or even if they have to allow the obstacle in the middle through them, some drones can go to the left side and some drones can go to the right side, and they can again regroup. But if the path is moving, then it involves more amount of calculation. That is, for instance, if a missile is attacking a particular airbase and we have to defuse that missile, or if some other drone is entering into our airspace and we have to destroy it, then that can be treated as a bogey and it can be attacked. So next, we are getting into the communication part, where this communication part involves UAV to UAV communication, UAV to ground communication. It can use satellites, and it can use ground station and cloud servers. So this Internet of Drone communication system uses is involving collision avoidance, then swarm coordination, and enable efficient task allocation. Then whatever that is getting communicated to the ground, uh, we can communicate through 4G, 5G, and some other radio frequencies or UHF and dedicated links for real-time data transmission. Then IoT-enabled systems. This utilizes cloud solution for real-time data sharing, analysis, and operation management. So what are the basic requirements for this communication system is it has a widespread coverage from 10 meters to 3000 meters altitude. So typically a drone flies from 30 feet to 9000 feet. That is what this UAV network requires. Then it has to communicate the UAV flight conditions, mission, equipment, and emergency control in real time. And if we are using Internet of Drones or AI integration in this swarm group, it has to transmit HD images or videos or thermal imaging or whatever sensor that we use. The multiple swarms has to transmit amongst themselves as well as to the ground. Any form of latency issues cannot be accepted because it will affect the judgmental nature of the drone, and it may lead to catastrophic failure of the entire swarm. So if two UAVs can communicate, all these are proposals that are done by researchers. Any significant improvement can be made by anyone who's interested in this area, especially ECE people. The automatic surveillance broadcast sensing method to avoid collision, such as point of closest approach, Dublin's path approach, and collision cone approach can be implemented. Then SATCOM links can offer UAV operators up to 200 kbps for less than 2 kg weight. But the main limitations are size, weight, and power requirements when it comes to this method. Then Wi-Fi radio links are modeled as interconnectivity between ground stations and two UAVs and are implementing functional and reliable proof of concept. This is just a proof of concept that has been achieved. Then LTE data link is beneficial for low altitude, high interconnectivity. So it can be only used for low altitude. Then UHF radio links can be proposed for UAV and UAV communications, where line of sight, near line of sight, and non-line of sight conditions is applicable. So UAVs have to be controlled by some ground station using wireless connectivity only. There is no chance that we can connect it through wire. So all UAVs has to be connected to the ground station. And if we are involving large volume of UAV, then a much intensified network with high rate transmission is required. UAVs in this form can utilize the communication, wireless communication to collect information, like velocity, heading angle from surrounding UAVs for coordinating their operations and maintaining target and UAV to UAV distance. Due to uncertainty of these wireless channels, communication amongst UAVs will experience transmission delay, which can impair the entire stability of the system. If a drone swarm is working towards a particular goal and they have to make a very quick decision, and if as a leader drone cannot make it, and if it relies on the ground station for the judgment, there shouldn't be any communication lag between this. In a typical area, the The communication, intensified communication is extended up to 2 to 3 kilometers. Beyond that, it is difficult. So communication latency can be caused because of device overloading. Then the distance between the ground station and the drones, bad weather condition, and if you are having a limited capacity of servers or hardwares, and any malfunctioning in the system, these things can cause the communication latency. But by any means, latency in communication should be avoided. So if we are connecting it through wireless, then anything can be hacked. That is an unwritten rule. So if we are connecting through internet, connect the drones through internet or any wireless means, any drone can be hacked by anyone with their expertise. So the basic threat is GPS attacks, Wi-Fi hacking, skyjack, and mall drone exploits. The solution we can propose is that a strong encryption, frequency hopping, then secured protocols like Mavlink and advanced security systems. It is very important that, for instance, there is a military surveillance drone. He's sending a signal to the ground station to the military people that there are some unwanted people or a weapon system by the enemy in a particular location. If the enemy is able to hack that signal, then what is the point? So robust cryptographic systems are crucial for data integrity, UAV safety, and maintaining mission confidentiality. So what are the security requirements that is needed is it should be uh, authenticated, confidential, and it should be readily available for whatever application that we are using. It should be integral, and it should be non-repudiation. That is, it cannot deny any responsibility. It cannot simply say that this is a reason so that I have walked out of this responsibility. So all these devices, any of these devices can be hijacked, or it can be involved in a human error or the system failure. So these things has to be avoided. So typically in today's research, we find 5G wireless networks give a reduced latency compared to 4G communication between drones and ground station for smooth and efficient swarm operation. It can give a data rate of 10 Gbps, and it is better than 4G. But one significant thing that we have to notice, 5G networks are very high frequencies. They don't go for long range. We need more network stations if we have to employ this. Then satellite UAV communication, which is mainly used by the military people nowadays. This can be used for civilians also. It will enable the beyond visual line of sight. A drone can travel from long range, say for instance 10 kilometers, 20 kilometers, that we can use. Then the frequency bands that are used for satellite UAV communication, including X bands for military application and Ka bands, which offer higher bandwidth for data intensive tasks. The frequency of bands can be researched upon. Then the orbit types, geostationary satellites remain fixed in a position relative to Earth, providing consistent coverage while low on Earth orbit. Satellites offer low latency and potential higher bandwidths. So if we have to process a large amount of data, then cloud computing comes as a hybrid model. UAV edge cloud model for data processing. Drones collect data, edge service perform initial processing, filtering, and cloud service handle large scale analysis and storage. The issues that we face is again latency, then concern for time critical application, energy constraints, and drone rely on battery power. This battery power is the main constraint for drones. If we are making a drone or a swarm of drone to communicate amongst themselves, then it requires a dedicated communicating devices. Or if it is processing a data, and if it has to think on its own, and it has to move, make a judgment, then we need to put a computer on its head to make that kind of judgment, which will consume more battery. If somebody is considering to put a computer on the drone's head, then from the aeronautical side, the weight of the battery has to be considered significantly. So the possible solution that we can see is AI powered resource optimization algorithms that can allocate computing resources across networks, minimizing latency, reducing energy consumption, and ensuring efficient operation. All these things are in the previous session. You would have noticed that they are future scopes. So in swarm of drones, these future scopes are not so far. They are all very near. But the only thing that we have to be focusing is that collaboration of all these engineers, um, cybersecurity people, then communication people. For instance, if you have to say ECE, uh, computer science, then aeronautical, mechatronics, all have to work in together to make this as possible. In India, if you are considering autonomous drones as a sector, only very few companies have come for autonomous drones. In India, we have a company called Vecros, which are trying to make in AI-powered drones. In foreign, we have around 10 to 20 companies. If we are able to make a startup based on the applications, then we sure will hit a jackpot in this area. So applications of swarm of drones, we have rescue missions, surveillance, bogey detection, warfare, disaster management, and firefighting. In typical rescue missions or disaster management, we can see one particular drone will be operated through one remote. Okay. And human intervention is very much needed to make it as a successful operation. And in recent floods in Tamil Nadu, that we have noticed that several people were stranded at several locations. So it was very difficult for the people to identify their locations and supply them with food and medical supplies. So if a swarm of drones can be enacted towards that operation, then it will be very much easier for handling such kind of situations. In civilian applications, already Amazon has been involved in package delivery, and some of the logistical people have also want drones. The only thing is that we have to increase the number of drones and engage them with autonomy. Then in media and entertainment, in modern days, we have seen a lot of drone shows happening in different locations, even in political gatherings, in temple gatherings, marriages, birthday parties, or in cinema functions, we can see. Then in infrastructure development, drones are being used for finding cracks, rust location in ships, and lot of other applications. And in smart agriculture, as we have told earlier, smart agriculture is a key area where the Indian government is trying to implicate the drone to work on. We can use for crop spraying, pest detection, and wildlife tracking. In crop spraying and pest detection, the main thing, we will not have any obstacles if the crops are below 5 feet. So we can involve much in smart agriculture as a start. In if AI in SOD applications, that is data processing, machine learning, and deep learning. And data processing, AI processes large volumes of data to enable autonomous drone operation. Machine learning models aid in detection, classification, and pattern recognition. And deep learning enhances complex decision making and enable more sophisticated tasks. So this is a line of applications that we can involve. So in challenges in drone swarming is that we have communication constraint. Then that is the first thing that we have. Then collision avoidance and power and endurance. Power and endurance relies on battery and the build of the drone. Collision avoidance is depends on the algorithm that we are trying to make for the swarm to propagate on. And communication constraints, it depends on the next future communication technology that are involved. Apart from this, we have some other challenges also, that is involvement of composites, advanced materials, and noise reduction in drones. A single drone can produce a large amount of noise, and it can be very much irritating in a very quiet place. And if we are trying to involve thousands of drones, maybe 100 drones, imagine the noise that it can produce. So it will definitely affect the flora and fauna by noise. So the propellers has to be remodified if we are involving a swarm of drones. This is the challenges. Where every challenges lies, that is an opportunity. So when it comes to opportunity, we can have enhanced autonomy, then virtual reality integration, and optimizing the swarm using bio-inspired drone techniques. And in future trends, multi-purpose swarms, where swarms will be more versatile, capable of performing wider range of tasks, like from logistics to surveillance in a single swarm can do, to environmental monitoring and infrastructure inspection. Then AI-driven autonomy is another trend, where drones become more autonomous, relying on AI algorithms to make decisions, adapt to change environments, and navigate complex airspace with minimal human intervention. Then security enhancements. This is a critical thing that we cannot overlook, because it is not necessary that a drone should contain an explosive to cause terror. A drone in airspace will look very entertaining and very pleasing, but when it goes out of control and it comes towards us to hit us, then it is the most terrifying thing that we can witness in our life. So it will be so fast, and suddenly happiness will turn into terrified thing. So security enhancements has to be done. So to conclude, the first thing is that integrating UAV technology with IoT or some other modern technologies, the focus areas will be AI integration, communication security, and energy efficient, which are crucial for drone swarming. Now, the potential that it has is, if we are able to integrate these things, then it will revolutionize a lot of industries with safe and efficient solutions. So that's it from my side. If anybody wants to ask any questions, I'm open for the session.
Thank you, sir. Participants, if there is any question, you can put in the chat box, or you can unmute and ask directly to our resource person.
Good evening, Professor.
Yes, sir.
Professor, as you said, it's the battery is a constraint of the power source of the drones. Generally, is the major impact about the usage of the drones in the multiple sectors. So, is it any alternative source of the power source rather than the battery?
Rather
Which
than
may be
battery,
effective for the
we cannot
conventional.
have any other power source, sir, because it is an individual device which needs its own power source. And the battery is the only device that can be installed in that drone. If we have to go for any other source, to my vision, I don't see any, sir.
Yes, sir. I accepted that also. So because of that only we have the lot of constraints, sir. So is there any alternate like that? Actually, already we have the agriculture drone and all we can use with the power of petrol or the petrol we can use.
Yes,
So
sir.
such an engine they have provision because of weight. There is no weight constraint in that. But in those things, if for our swarm drone considerations, the weight is also the factor. How to be and the size is also a compactable. The main thing there is like a fuel cell in techniques. The fuel cell
Yes, fuel cells
concept.
can be used. Alternate fuel technology, like we have in our college, one student, we have developed nitro engine drones where nitrogen uh, type of fuel was tested and it started flying. Um, some typical known fuels only we can use, sir. Other than battery, if we need some other wireless technology for enhancing energy, then it's beyond the scope at this point. But if we can use fuel consuming engines and fuel cells like that, sir.
Okay, so thank you, sir. Thank you.
Yes, sir. And in the session, I mean in chat box, can I use swarm of drones to follow some vehicles in a jungle? What are the technological changes? Sir, in jungle, the first problem is we don't have any um, connectivity. Uh, Even cell phone towers will not be there, radio signals will be not be there. That is why communication is the biggest problem that we see. And in jungles, if we have to track some vehicles, what are the methods that we use to track? What is the sensor that we are going to use? That is also will be crucial for tracking vehicles, sir. For instance, if we are using some camera or thermal imaging system, then that has to be implied proper accordingly. From HOD EC, sir, any industrial application where IOD is used, sir. Mm, currently, autonomous drones are restricted to are having lot of constraints. Individual drones with remote piloted drones are used for a lot of industrial applications, sir.
Yes, thank you. I think can child drone works at different speeds? Can child drone works at different speeds and use for different purposes? So there are two more questions.
Yes, sir. Child drones are if they are built in that way, we can use it for different speeds, sir, and different purposes. If child drone in the sense, is it an entertaining drone or
I think I don't know what he's trying to say, sir. I think we can go for the next question from
wireless
Dr. Santosh.
communication?
Yes, sir. You can ask
Wi-
directly. Fine.
Wireless communication to cover hard reach areas where cellular coverage is not available. Some researches is happening in that session, sir, where drones will itself be the communicator, will transmit the signal to other drones or send signals to camps. that is being researched. What is your view on solar-based drones? As far as I've seen in solar-based drones, ma'am, the power that is produced by the solar panels has to be adequate with the power requirement of the drone. That is the only thing that we have to cross for the drones in when it comes to solar-based drones.
Yes, sir. I think that's all with the question. If at all, I think we can end this session.
Okay, sir.
Yes.
If that
Thank
is
you, sir.
all,
Thank you.
thank you for the session, sir. I hope it is engaging.
Yes, sir, for sure, for sure. Thank you, sir.
Okay.
Thank
Thank
you
you,
for
sir.
your time. Participants, thank you once again for joining the day 3 session. Tomorrow we'll be meeting again by 6 p.m. Tomorrow again we have planned for another 2 sessions. And another kind reminder, participants, those who are joining, try to join with the mail ID that is used in Atal portal, because even yesterday we had a few difficulties in identifying your name for giving attendance for yesterday's session. So, kind request. Probably tomorrow we will be trying to share the attendance sheet what we have received, so that that might be helpful for you, because if we get a clear picture about the person who's attending, so that it becomes easy for us to mark your attendance. And as mentioned earlier, I'm trying to collect PPT from all the speakers, and we'll be uploading it. We'll be uploading in our WhatsApp group, and the recorded sessions also been edited, and very soon we are going to upload it on our YouTube channel. Once it is done, we'll be sharing it in the WhatsApp group. Thank you all. Thank you all once again. We'll meet in tomorrow by 6 o'clock. Thank you. Good night.